Okay, welcome everyone. Can you throw up your hand if this is the first time you've paid to AWS user? Welcome. No doubt you've signed up via Meetup in order to get here. All of our events are published through the Meetup platform, even when they're held in different places and different formats. So just keep looking at your inbox and you'll see what's coming up next. Who has not heard Josh speak before? Nice. Okay. Occasionally you get to introduce someone who you can say wrote the book on something. Now, tonight your book is about cloud native security.
Yes.
Which is in the testing is a bit about
security. Yeah.
It's tangential, but anyhow, Josh has written a book, and it's kind of the book. We welcome him tonight. We believe he may have presented to this user group in the before COVID times.
Yes.
Which was a while back. So we welcome you back.
Thank you.
And of course, we have to say something about the gold jacket. Were you going to introduce the gold jacket concept, or are you just going to?
Yeah, I mean, how many people know what the gold jacket is for? Yeah, a lot of people. It means I am that special kind of nerd that wanted to complete every AWS cert at once. I've since let them expire. But it was a nice completionist challenge to scratch an itch. And then I had kids, and I will never set another one again. But that is what it is.
All right. Thank you, Josh.
Cool. It's warm, actually, with the jacket. I made my point. Hopefully someone else in Perth has got one now. I was the first one, I got it last year. Okay, serverless testing, local considered harmful. I like to play on the go-to considered harmful from Edward Dijkstra in kind of computer science history. This is based on a number of years of doing a lot of serverless development and kind of just making sure that what I was doing was coherent and made sense around testing. And I'll get into it as we go, but kind of there was a bunch of bits we picked up and started doing around serverless and testing in other spaces where we kind of just picked up the old practice and the old approach without rethinking whether the idea of serverless changed anything fundamental and whether that enabled us to do something slightly different. So hopefully over the next 40 minutes or so, if I might convince you to look at things a different way, you might vehemently disagree with me. I don't know, we'll see where we go to. I'm happy to take kind of questions, comments, heckles as we go as well, because I'm going to cover quite a lot of different things. So rather than kind of hold it to the end and have that kind of distance in there, happy to take as we go. So it looked like quite a few people haven't seen me speak before, but I did decide to throw up a bingo card at the front for people who have seen me speak before. You will realize these are kind of some of my favorite topics I like to talk about. I think of these 15, I'm going to cover 14 in this talk, and there's going to be a prize if someone can remember the one that I didn't talk about. So, and another warning that goes for all my talks, strong opinions ahead. I like to think they're loosely held. We'll see if anyone starts to disagree with me how loosely I can hold them. All right, so this is a friend of mine in the UK who does actually own that suit. He has one-upped James Bromberger in the fact it's more than just the jacket, he has the whole thing. And he's drunk the cloud native Kool-Aid. And when I say cloud native Kool-Aid, I don't mean this thing. So this is the CNCF landscape. So it's actually circa 2022, I realized, not 2019. I got my DDDs confused. So this was CNCF landscape only 2 years ago. It was already kind of an unholy Cambrian explosion. Nowadays, I had to put it on 2 slides because it's got unbelievable now. So it's an interesting one where, when we talk cloud native, unfortunately, the CNCF, and there's so many people that argue about definitions and all that kind of stuff. And I'm just kind of going to give the definition I want to use for today, which is building for the cloud, not just on the cloud. So this can mean Kubernetes. Normally, I would see it manifest as serverless, architectures used, managed services wherever possible. I do think the term serverless has been diluted significantly in the last couple of years, which is really unfortunate. The lack of the fact that scale to zero got taken off the definition pains me to this day, and when AWS aren't talking about Bedrock and other Gen AI services, generally they're actually getting slammed over the fact that serverless doesn't mean what it used to mean. And now it just means it kind of scales, but there's normally a cost at the end. This is a more modern thing that I kind of came across last week, which is an interesting one. And if people aren't familiar with Theo, he's like a YouTube tech influencer, used to work at Twitch, builds his own stuff, another strongly opinionated person. But he was coming out of this idea of where you're driving your value with your products. I just thought it was interesting in the kind of serverless Kubernetes space. Not necessarily has all that much to do with testing per se, but in terms of when you're picking cloud native, what should you be picking? And really when you look at products, the value tends to either front-end centric, you're providing like a really good experience, or back-end centric, you're doing something algorithmically complex, or some scale piece, or something else is where you're driving value. Say, Twitch, back-end centric, be able to actually do that is really important, but most of the stuff we kind of use day-to-day is normally front-end centric when people spend far too much time in React doing things. But when you're front-end centric, serverless makes a lot of sense. If you're back-end centric, it makes less so, and that's normally when you're going to kind of grab for Kubernetes or something else because you're trying to provide something fairly custom. But in reality, most of the stuff we do should be serverless and front-end centric because we're normally augmenting some of the process, and it's more about providing experience and augmenting something else rather than doing something algorithmically challenging, which somewhat sad for us techies. I think the back-end stuff is generally more interesting, but this is just kind of what it is. So back to Rich, back to kind of the story for today. So these are the kind of 3 key lessons that Rich learned once I shouted in his ear for long enough about this stuff. But the first, that the testing pyramid is a serverless anti-pattern. And I'll get into what you can use instead and kind of why that is. Second is emulating cards as a recipe for disappointment. This is normally the one that gets the most anger and ire out of the crowd, but I'll explain why I think that and kind of show that the industry is moving in a direction away from cloud emulation, especially in the serverless space. And the third is that testing doesn't stop when code hits production. There's lots of memes, and I will use a couple of them later on around this, but effectively, when you're looking at this stuff and you're trying to move quickly with high confidence, there are, again, some old-fashioned practices or other, maybe not old-fashioned, maybe not the right word, but other practices that we generally pick up because we're used to them, but we haven't really thought it through based on what serverless changes. So a little bit about me. Christian did a very lovely intro. So yes, I did write a book with O'Reilly while I was stuck in lockdown in the UK around cloud native security. 1/3 is AWS, 1/3 GCP, and 1/3 Azure. I'm the cloud practice lead for Asia Pacific and Japan for Cognizant. I run the local tech consulting team here in Perth, and then I look after our cloud practice in a much wider space. Been doing consulting for a number of years. At least according to AWS, some of the serverless stuff I did a number of years ago was world first around event sourcing. I've done mainframes, I've done machine learning. I speak far too much. And also, I'm one of the local organizers for Beer Ops, in case people, I have to spruik it, in case people haven't heard of it before. So Beer Ops is Australia's biggest tech networking event. It just so happened the mid-year event for Perth was last week. But there'll be another one come November. We had over 500 people there last week, and it's free to enter for attendees. It's a great way to kind of just meet the wider Perth tech community. I think nowadays we are the second biggest tech event after DDD, and we are rapidly, bearing in mind we went from 380 to 550 with the second event. I think we'll kind of get on par with DDD very, very soon as well. But if you want to meet people outside of the meetups and everything else, it's a great thing to go to. As I said, it's free for attendees to come to as well, all sponsor backed. Clicker, no, died. All right. So I'm going to talk about functional testing today just to try and focus in and all that kind of stuff. There's lots of other kinds of testing you can and should be doing, but I'm going to focus on functional testing for today. It's the one everyone thinks of, and it's kind of the one that if your thing doesn't work, you kind of can't do anything. There are definite options around security testing and how much you want to do or not do, and the consequences of that as they bite you in the ass way later, but that is what it is. And you'll notice in the bottom right, there'll be random book covers appearing. So if whatever on the slide looks interesting, if you haven't come across it before, I've tried to put book covers in the corner for where I've got it from or just good reading on the topic. So why do we test? I think it's kind of fundamental to get back to the point of why, just to make sure we're all in agreement on what the purpose is and therefore what we should be doing about it. So is it to prevent bugs? Is it possible to prevent like all bugs? Well, no, is the short answer. The slightly longer answer is we build complex adaptive systems. And for anyone familiar with the Cynefin framework, which is the thing in the top right, we're playing in a complex space. What that means is no matter how smart you are, you can't understand the full ramifications of a change before it's made in here. So, and secrets with event sourcing is an exception to this. It's another strong opinion I have. That's a completely different talk, but I like to put it there just in case anyone wants to come and argue about it with me later. But for the purposes of this talk, we're playing in a complex space. So, and if you don't believe me, this is quite a good one, and this is something we've all had. It's like, did you finish your task? Yes. Yes, they found a new bug. I'm fixing it, right? So, like, as smart as we all are, and as much effort we put into our craft, realistically, this happens, and we kind of can't get away from that fact. So we need to just own that and find ways of dealing with it and mitigating it elsewhere. So when you're looking at system behaviors are a system and an emergent property of a complex system. So behaviors are not kind of designed in, they are emergent from the interactions between the components as much as we try and design them in. And because behaviors are an emergent property, it also means unintended behaviors are also an emergent property, and unintended behaviors are generally known as bugs or features depending on your disposition. But effectively, and this really does date the talk a little bit, but I think Endgame was about coming out at the same time. But effectively, bugs are inevitable. They will happen. They will get through to different stages through to production. We can do things about it to reduce the likelihood, and I'll get into that in a second. But when we come back to what we're trying to achieve with testing and quality engineering and all that kind of stuff, we're trying to assert this. We're trying to assert that the value of the release is greater than the risk of the release, with some level of buffer based on your risk tolerance. We'll kind of say the unit of change that we're going to make, the expected value is greater than the expected risk. Therefore, it's something worth doing. And when you take that risk angle, quality engineering is about reducing the likelihood of risk. And then reliability engineering, operations, all that kind of stuff in there is about reducing the impact in here. So these two things combined are two different levers you're going to pull. Again, I'm not going to talk about the bottom one today. I could talk about it for hours, but not now. But the quality driven I'm going to talk about a little bit more. And for those of us unfortunate to either work in enterprise or work with enterprises, which is most people, just to put it over a risk matrix to make it obvious and make it palatable for enterprise types. More just to, then when they come with a risk matrix, you can start to understand. And if you work in an ITIL environment, second, effectively the whole concept of standard changes you're over here on the left somewhere. So if you do reliability engineering is mature enough and you've done quality engineering, you end up down this bottom quadrant, and that's when you can start doing your standard changes and start getting stuff through and dodging most of ITIL. And if you're going on DevOps and you don't work in an ITIL shop, then just forget this ever existed in the first place. So if we take the premise that we want the value of the release to be greater than the risk of the release, then what we're trying to kind of ascertain is how cheaply can we be confident that this is the case? And we can never be 100% confident, because again, we're playing with a complex system, but effectively we're trying to really cheaply find where we're happy that this is sufficed, effectively, the value of release is high enough. I like to use lean theory for a lot of things to understand this stuff, but effectively, lean then gives us an idea of where we're driving cost in terms of ascertaining this. And one of the parts of lean theory splits kind of all activities into one of three different buckets in here. And as a consultant, I love my mutually exclusive, collectively exhaustive buckets for things. One is value adding. The only value adding thing we do in software is development. It's the only thing. And then when you get to testing and all that kind of stuff, like automated testing is necessary waste. And then the manual regression testing, which unfortunately is pretty ubiquitous in a lot of places, that's unnecessary waste. We want to get rid of that entirely. And what we want to do is kind of optimize necessary waste to make it we want to be as effective as possible and as efficient as possible. There is a natural tendencies in enterprises to really dial on efficiency and not look after effectiveness. as much, but realistically, again, you've got kind of two levers to pull. We can do better quality testing, or we can make the testing run faster. Both things are good, but you want to be doing both. Another way of looking at this that is a really good way of kind of something practical to kind of go and take away and do is looking at the value stream of what you're trying to do in here. So a value stream can be defined as from please to thank you or other bits and pieces in here, but effectively looking at how code gets from developer machine to production. You can extend it slightly on either side, but effectively, this way of just looking like what are all the stages we do in here. And I've kind of got 3 key metrics along here as well. So the top one, the percentage CNA, is percentage complete and accurate. It's probably the least commonly used of the 3. No, it definitely is the least commonly used of the 3. But effectively what it's saying is how often is the work arriving at that stage of sufficient quality to get through that stage. So, and I'll dive into the UAT example a little bit more in a second, but effectively that's how effective is our testing at catching things. If arguably the lower the percentage, the more effective the testing because we're catching more things in here. The cycle time is how long it takes, and the wait time is the time between the different stages in here. The numbers are indicative. You'll find they change everywhere you go, but it's a really interesting way of kind of looking at what you're doing, kind of that DevOps ideal of working on the daily work, or the lean theory approach of Gemba walking and just looking at how things are working and then using that as the basis for what you're going to improve. Value stream map is a fantastic way of doing it. Flow engineering is on sale on Amazon, the Kindle version for $8, I think for the rest of the month. It's fantastic, go read it. It only came out about 2 months ago, but it tells you how to do this, how to approach it, all the different steps you need to do, and more besides. So if we look here in terms of the bits of the value stream in here, where are we actually doing testing? Not gonna argue TDD and development or whatever here, that's not gonna go down that rabbit hole right now, but effectively in here we've got 3 stages where we're doing testing, and we've got an idea of how effective we're being and how efficient we're being. So those 2 levers I talked about earlier in terms of we want to be effective and efficient, we've got an idea of doing this. If we kind of double click in on the UAT section in here, the percentage complete and accurate is 50%. That means we're being really effective here, but it does mean the quality of the work arriving at user acceptance testing is problematic because there's a lot of problems here in terms of actually getting the work arriving here is of low quality relative to the testing. We're also being inefficient because it's taking 10 days to do and we're waiting 5 days to do it. This is just really classic. The UAT becomes a problem in a value stream because it generally takes a long time. You're waiting on people, and normally you're actually finding quite a lot of stuff as well. The interesting thing about this is when you actually look and kind of go across the top with the efficacy, what you can do is you can roll all the percentage complete and accurates together to get an idea of every kind of bit of change you want to make, what's the percentage of them that go the whole way through the process without requiring some kind of rework. Based on these numbers, it's under 40%. So more than 60% of work on this value stream has to go through some kind of rework as you're going through, which is not good. This is just, I'm working on this at the moment, which is why I work in progress at the top, but this is kind of like, if you're at that position, you've got like the UAT, like what can I do about this? This is kind of me trying to pull all the different kinds of testing and different options around quality together in a way that hopefully makes sense with enough time looking at it, and I kind of need to step through it, and I don't have time today, but I'm happy to go through this with anyone afterwards if they're interested. But effectively, this is trying to pull all of them together so you can understand, okay, based on what our problem is, what should the next thing we do be? As opposed to kind of, well, we could do fuzzing, we could do mutation testing, we could do test-driven development, we could do smoke on the end-to-end. Like, what's the next thing we should be doing? And this is a tool, it's called Wardley mapping. It's fantastic. Again, I kind of don't have time to do a full intro of it, but effectively this is a way of trying to understand what's the next best action we should take. So instead of trying to go, well, that sounds cool, how are we aligning it back to the things we're trying to change? So again, circling back to where we were with Cynefin before, I said we're playing in a complex space, and what that means is we have enabling constraints. And those are constraints that kind of stop us falling too far out of where we're trying to aim for in here. So realistically, what testing is doing here is allowing us to explore the space and try different things while trying to preserve certain behaviors we think are valuable and important, or preventing behaviors we don't want to see in here. So really when you get down to it, the tests are just about, they're an attempt to try and preserve behavior in here, but they're not going to be exhaustive. They're going to be things that are going to be missed. And this is just a great quote, and I have to reference a Google book every time. But like the Beyonce rule, if you like to sort of put a CI test on it, this is just kind of almost like doctrine at Google that, your CI should be checking everything that you care about in here. If you're relying on other people and UAT and other bits and pieces to check the behavior is preserved, you've got a problem. Ideally, CI should be catching as much as possible in there. Because just to go a little bit deeper on this, testing is refining our mental model because we've got how we think our system works and how it actually works. And testing alerts us to the fact when those two things are out of sync or sufficiently out of sync. So we think it operates like this. The test will then tell us, well, no, it doesn't, because I've checked something. I've checked the behavior and said it doesn't work. So testing is this constant refinement that brings your mental model closer to the actual model of the software you're running in here. They'll never be 100% synced, but it's all finding those times when they're too far out of bounds in here. And there's a great quote from Alberto Brandolini on this, which is, it's developers' understanding or misunderstanding that gets released in production, not your domain expert. Alberto is the inventor of event storming, if you're familiar with DDD stuff. But this is really true. It's like this idea of it's our mental model, our view of the domain and everything, that's what goes into production, not necessarily what the domain expert thinks should be there. A really common refrain, I feel like it's getting less so, but especially a couple of years ago and before that, the common refrain with serverless, God, this is hard to test. This feels really, really, really hard to do. And within the serverless community, there's an idea that serverless is a mindset, and it is a technology paradigm. It is a sufficient shift to warrant new ways of working in here. So if you try and just go, well, I'm going to deploy on Lambda, but I'm going to do everything the same way I used to do, you're going to have a bad time. And I think that's still that used to be where a lot of people fell afoul, and I think people are still falling afoul of that today. I'm going to kind of talk about kind of coming back to deciding what the ways of working should be based on the principles underlying everything we're talking about. So when you do cloud native development with a pre-cloud testing approach, your local dev setup is hellish. You're trying to run like multiple containers running Lambda functions and dependencies and everything else. Your MacBook's set on fire and it's really brittle and you end up spending half your week trying to make it work as opposed to doing things. Testing across multiple services is brittle. This is just kind of just general microservice problems, but generally, you know, we in a monolith sense where you're running like a giant Java app in a JVM, you're kind of used to everything just being there and you can kind of just test through things very easily. When you go down a serverless route and you're trying to do this breakout of pieces and microservices, you find if you keep trying to do that, you find it really hard instead. And the last one is hard to write impactful tests. So you end up with lots of testing that's kind of not effective, and then you end up with giant test suites you like, but it doesn't actually give me any confidence, but I got a lot of testing. There's probably an argument to be made around unit testing code coverage here, but I'm not going to do that right now. There was kind of wider IT, like wider economic effects that kind of went into this. And some of these are still happening. Some of them are now going backwards a little bit as well. But historically, IT was seen as a cost center. A lot of places, unfortunately, still is. But there was this drive towards IT as an innovation center. AWS, big hand in that, actually trying to drive that out as cloud being your innovation engine, as opposed to just somewhere to dump the VMs you don't want to look after anymore. There was a move from monoliths to microservices. We kind of went too far one way. We're now coming back to some kind of medium between the two. It's still, there's lots of balls of monoliths that are problematic, and microservices are seen as a solution. They often are. And the last one, and this is kind of one of the key ones for the testing bit, is it used to be, I need like a SQL Server database set up. I'm going to go raise a ticket in ServiceNow. That will go to an infrastructure team. They're going to pick it up when they have time in 3 days, and then it'll take another day, and in a week, I might have a SQL Server box sitting there for me. So realistically, at some point, everyone starts piggybacking on the same SQL Server because it's too hard to go get more stood up, and it's just problematic. There's licensing, VMs, all that kind of stuff. And really, with the cloud, most infrastructure is instantaneous. There are exceptions like EKS control planes that take quite a while, but there's ways around that as well. But when you're talking in AWS parlance like DynamoDB or, a a lot of the other services like SQS or SNS, or kind of all the services you're going to be using, a lot of them, and especially in server space, are your Terraform, your cloud formation is going to take in the order of 10 seconds to stand it up. Maybe a minute, depending on how much you're trying to do. So this kind of does start to change things when it went from multiple days to seconds to minutes to get things. The other bit that was kind of driving things was the Accelerate book and then all the state of DevOps reports that started to come out. That started kind of painting a picture of what good looks like with some proxy metrics. I don't know how many people are familiar with DORA and state of DevOps reports. A few? Okay. So effectively, there's a bunch of research done on some proxy metrics that are very strongly correlated with just general performance. In here, change lead time, deployment frequency, change failure rate, and failed deployed recovery time, or mean time to recovery as it used to be. They like to change the definitions every year. But effectively, this started to cluster people in between different teams. And what you generally saw was that over time, teams were getting better. Enterprises were getting better. It started from 7% elite to 26% in 3 years. All that kind of stuff. So you're seeing this trend to higher performing, and there's kind of this drag on like, well, we need to be high performing as well. A lot of enterprises are using these kind of North Star metrics nowadays. They are something, if you're not familiar, you can go and find a report. They're all good reads, but it kind of gives you an idea of what good looks like. And then this is more enterprise scale, not just two-person startup sitting on a table around here that can kind of do stuff really, really fast. The other bit around serverless was there was this fundamental change from a simple arrangement of complex objects. So you'd have EC2 machines running a big hunk of Java or C# or whatever your flavor in here, and the complexity was generally within the code there, but the infrastructure was relatively simple. Then we moved to the idea of a complex arrangement of simple objects, with the idea that every piece is easier to understand in isolation, but instead I have to kind of understand how they're working together instead. What this meant is that complexity has moved from within the service to the integration between services. So now when I'm actually trying to get confidence in a change, it's not necessarily does my Python code work the way I think it should, it's does it integrate with DynamoDB? How is it, is SQS set up properly? How am I actually testing kind of the equivalent flow when it now spans multiple services in here? I think this is one of the things that really tripped a lot of people up and continues to on this. People got very used to being able to kind of test to high confidence locally just by running paths through their monolith application. And that's where we kind of got the test pyramid from in here. I imagine most people have seen this a million times to death. What Shopify started talking about was the idea of a test honeycomb in here around microservices. So instead of having lots of unit tests, you would have implementation detail, but a lot of integration tests as kind of your driver, because every bit is kind of individualized to the point where realistically it's about testing where the complexities and interactions is kind of the bit where you need to test more so than within the microservice itself. So the question then kind of becomes is, well, this implementation detail, is it small? Like how many should I be doing? What should I be looking at here? And it comes down to a kind of an idea of complexity in terms of what's within the service. Kind of two ends of the spectrum in here. So you've got what I've called Lambda stitching. I used to call it Lambda as glue, but then glue is another AWS service and it was just too confusing. And then you've got business systems on the other side. So for Lambda stitching, this is effectively where you go, I've raised a feature request to AWS to add something to a service, but they're taking their sweet time about doing it, and I need something to do it in the meantime. And then AWS generally have a habit of going, well, this is how you can hook Lambda functions onto other service to go and do things for you. So a lot of the time, this is just kind of like, I'm planning on deleting this as soon as AWS pull their finger out and do what I want them to do. But you end up doing a lot of this around the edges, especially, and I'll get into a little bit more around, if you're running like an AWS cloud platform, you're responsible for the AWS platform itself, you end up doing a lot of this just to be able to kind of pull bits together and kind of make things work. Or you get business systems, which are probably the things most of us are actually building, where there is a business domain to be modeled. And then you're going to have more implementation detail tests in here, more akin to unit tests in there, in kind of the test pyramid in there. But again, you've kind of got small segments of implementation detail. You're not having like the giant piece in there. And generally you're offloading like things to step functions or elsewhere that normally you would have had within your code itself, but instead you're kind of handing them off to other services to do. So the best thing to do here, and I know Christian and the Journey 1 team do like a hexagonal serverless workshop, which I haven't been to, but I'm assuming this is gonna be on point for that in terms of what to do. So one of the key things to be doing when you're doing these systems is you need to be isolating your side effects in here. So when you've got a domain you're trying to mold because you're building an information system, you should be able to write, test, and do everything with your domain without touching anything in AWS in there. If I have to, talk to DynamoDB to test my domain logic, something has gone awfully wrong. But it's very, very common to see that, and I'll kind of get into some of the strategies you can do around that in there. But effectively, normally what I see in the projects I run and the ones I have influence on is you kind of have domain tests, integration tests, and some level of smoky end-to-end tests that are just doing a few things on the edge as well. Or maybe there's something testing like at the API layer or something else as well, maybe some contract testing or something there. So there's this idea of splitting domain complexity from architecture complexity. Pick your poison in here, ports and adapters. I've kind of named all the ones that people might be familiar with in here. They kind of all do the same, different takes on the same thing, which is my business domain is separate from my deployment model and my architecture and my data store and everything else. Like my business domain doesn't understand any of that stuff because it has no need to in here. There's a new book from Alistair Coburn about ports and adapters / hexagonal that came out pretty recently. There's a clean architecture book from Uncle Bob, or just Google any of these and you'll find a million links about them all in there. But when you're writing serverless applications, if you don't do this, you're kind of gonna pick one of these, you're kind of gonna have a bad time where all of a sudden it's like, to do anything, I need all these AWS resources to be available to do anything. Whereas you should be able to build out your domain and then kind of go, I'm gonna stitch DynamoDB on the edge here just to do the data storage that I need it to do, and have that separation in there. What that looks like, and this is just a make file I stole from our open source project. An open source project we used to build as Contino around, I've got idea of unit testing in here with PyTest and integration test. So I have these kind of separate sections in here where I can test my unit tests and my integration tests separately and then do like my CI test of check coverage under everything in here. Because I actually, in order to get coverage, because my unit tests are only testing my domain, my coverage will fall well under 100 in here. So I need to do integration and unit tests together to get my coverage as well. And yeah, the project started at 100% coverage and never dropped underneath that, which was an interesting one. I'm happy to argue the value of whether that's worthwhile maintaining or not. But effectively, this ends up splitting into my domain tests and my driver tests. If you look at clean architectural ports and adapters, you'll find kind of definition of drivers, but that's kind of the things that are driving externals to my system, whether that's databases, web front ends, pub sub queues, you name it, all that kind of stuff in there. So I'm testing them independently of each other and then kind of got an end-to-end just to make sure they're stitching together properly. But this allows me to kind of run a local dev loop on domain where I don't need to be connected to the internet at all or doing anything. And then as I work on drivers specifically, I need to talk to AWS or something else. One of the testing heuristics that I've tried to live by most of the time is if I deleted all the code, left the tests, how confident am I new code would work? I'm a strong believer in kind of unit testing is there to support refactoring. I think if you I've actually done this. I've actually taken serverless functions, deleted them entirely, left the tests and rewritten them from scratch because I was getting very angry at the code that I wrote about 2 weeks before and I thought I was slightly smarter now on the second attempt. But this is a really interesting heuristic to try and get to where if your testing is good quality, are you confident that you could rewrite your function from scratch? If not, you might want to revisit how you're testing in there. So yeah, this local stack, I'm now going to bash it quite a bit. It has its uses, but this was kind of the really common thing that I was seeing, and even internally at companies, even at Contino when I was there in the UK, I had this argument about a weekly basis with people around the applicability of local stack. So people just assume because you can run AWS locally, okay, well now it's like when I used to run my Postgres database locally, it's the same thing. Everything's wonderful. Wrong. One of the problems with this is local stack will never be a 100% fidelity replica of AWS behavior. It's fundamentally impossible because, again, going back to complexity and complexity theory, to have the same behaviors that needs to be exactly as complex or more complex than the thing it's emulating. So local stack would have to rebuild AWS entirely to be able to test locally with AWS. So you're always going to find some problems there. And don't get me wrong, they've done some phenomenal engineering to get it really close. But that fidelity drop, it stung me in the past where I've had it just not act quite right, or when I'm waiting for like a DynamoDB stream event to kick off and hit my Lambda and all that kind of stuff. There's a variety of things it just kind of can't do, or doing it feels really hacky. And there is the identity piece as well in terms of the amount of time, people will have surely had this, where you have like a serverless function, you're testing locally, everything looks fine, you're running against like AWS resources, you push it up, you do it, and you realize your IAM role for your execution role for your function isn't even close to what you need it to be. Because it was acting as you and now it's acting as something else, and then you kind of go through that loop, you've already kind of worked on it, you're already behind, you end up slapping a far too big IAM policy on it because you're getting pushed to get it out the door, and your security posture then starts falling apart. It's much easier if you are building in the cloud directly, and as you're building out the functionality, you're getting the IAM message of what you're missing as you go, and you iteratively build out the policy specifically from there. So, test doubles. Why do they exist? Why did we go down this path of thinking test doubles were a great idea in here? So, fundamentally, test doubles exist because the dependency was too expensive. So we're making the call that the cost of the dependency is more than the cost of the test double. So generally in the past, and still in some cases, say you're integrating against SAP or something like that, that orchestrating SAP around is expensive, it's hard to do, it costs a lot, you're reliant on other teams, all that kind of stuff. It's like, okay, well, at that point, yeah, looking down test doubles makes sense because this is just too hard and too expensive. But the cost of a test double is the development effort that goes into it, the bugs from loss of fidelity, and there's just additional code complexity about orchestrating them and doing all this kind of stuff in there. So they're not for free, far from it. But this is kind of the balance you're trying to strike, like which one is cheaper for us to do. If you look at serverless dependencies, all these things that were high cost, say in previous, if you're like, I'm just going to use DynamoDB as the example, but hard to configure, it's now infrastructure as code, couldn't be easier. High running cost, it's serverless, but on the old definition, so it's pay per use. So you can kind of leave it running forever and all that kind of stuff. It's not going to cost you anything. And depending on other teams, now a lot of the time, like a lot of the functional silos we used to have around database admins and all that kind of stuff, they don't really exist anymore. Generally, teams are empowered to run their own data stores, especially in the microservice world, because you kind of have to. So at this point, it's actually, well, all these things that used to make the dependencies really expensive, none of them apply anymore. So why would I start using test doubles like localstack? As much as localstack isn't that expensive, but the fidelity one will bite you on occasion really annoyingly. And also localstack lock quite a lot of services behind a subscription fee as well. So depending on what service you need to play with, you end up having to pay localstack for the privilege of using them in there as well. Don't know how legible that is in here. So what the pattern that we always followed in here, we were using Terraform for all IAC, apply any different IAC in here, that's kind of neither here nor there on this, but effectively these are just PyTest fixtures that if I set a local environment variable, then I run the infrastructure up and I just leave it there. So rather than, because one of the common refrains to this is, but if I have to stand up my infrastructure every time I want to run tests, that takes too long and it's going to slow me down. And my point was, well, but it's serverless infrastructure, it doesn't cost you anything, it scales to 0, leave it there while you're in your local dev loop. I don't understand the problem anymore. And then from a CI perspective, you are clearing up and destroying it after every time. So you are leaving your AWS environment clean afterwards. But this allows you to kind of go, well, I need these 3 services stood up in order to be able to run my tests. Cool, run them up. And then while you're there deving, leave them there, test against them, it's fine. I think when I did some maths on the back of an envelope around DynamoDB costs, it was like based on kind of some indicative amount of tests from a team running as DynaB, you're looking at dollars a month at most in terms of cost. It's not even going to get more than $10. Like I've had a startup at SpaceCube that I used to help. They were running a production system with DynaB. They didn't get out of free tier. Like realistically, you're trying to optimize, like devs we are very expensive people. To get your cloud bill and the serverless angle around testing, to get even close to your cost on the day, I'd love to know what you're doing to get even close, because I just can't even fathom how you'd even get there, to be honest. One for the platform engineers in here where you are working against AWS directly. So a client I had in the UK, I was the tech lead on a AWS platform team where we had 3 organizations because of historical reasons. And on I think when I left, it was about 600 accounts across those 3 organizations. And I'm pretty sure they've added a few hundred more in there. So we're trying to build a platform that would stitch them all together. And realistically, when you're a platform engineer, instead of having a business domain, your domain is AWS. That's kind of what your change out is. Well, actually, AWS is my domain that I'm trying to understand and be able to orchestrate. I'm no longer looking after a business domain. So on that kind of dependency orchestration, there are AWS services that are very, very hard to orchestrate. AWS config is a perfect example in terms of it's going to constantly run and get new numbers, so your testing is going to break every single time you run because the amount of S3 buckets that are failing your config policy, it's going to change, especially if you're trying to look at it at an org level. Like it's a constantly moving target, so how can you test? And for Python fans, there is a fantastic a fantastic library called Placebo. If you're used to like snapshot testing in front end, like React and stuff like that, it does the same thing. Effectively, it will go and capture all the responses from AWS on those APIs and store them. And then you can kind of get it to play back your responses in there. So you can get a static path, but it's not some emulation of AWS. It's a point-in-time version of AWS. So you do need to refresh it occasionally, but you'll kind of re-record, fix all your tests without changing your code and kind of set it back up again just to make sure you're staying consistent. But this gives you kind of a static view of AWS to test against where you can actually test your logic in here. So for example, in this case, I was looking at EBS backups across the organizations. So I needed like the amount in not covered by plans and not protected to stay static so I could actually check my logic was doing the maths right, for example. So there are ways and means of getting around some of these things. What I said back a couple of years ago was use SAM Accelerate, not localstack. It was really, really new at the time. Effectively, it was live streaming your code changes up into AWS as you were developing. And that would allow you to actually test your Lambda function constantly because you're using AWS CLI to kind of replace the code in time. So, there'd be like a couple of second lag depending on your language and if there's build step or not. But you could get like that kind of really fast feedback loop like local, but actually testing against a Lambda function in there. And I said this was the future. And yeah, what I was trying to get people away from was the idea that instead of refining a mental model to a software model of how it works in AWS, what we're doing is refining a mental model for how it works in localstack, and then again refining it to AWS. So this step was just kind of redundant, and that was where that lack of fidelity in localstack starts to become a problem, because the fact your code works with localstack is useless. Doesn't drive any value. So now in 2024, SAM Accelerate's still there. SST has live Lambda deployment, which is a slightly different take, but the same idea of how can I use AWS resources properly, uses AWS IoT and some interesting stuff. I was reading about it today. It's quite interesting, actually. CDK Watch is like SAM Accelerate. Wing Lang has test targets, which are the same thing. And for Amped, where Jeremy Daly and stuff have kind of spun out of serverless, that is how they run. Amp does this by default. It doesn't really work locally. Serverless framework, if anyone does know of a plugin that does it, I'd be cool to know, but I couldn't find one when I had a look. I haven't used serverless framework in a long time, ever since they were kind of sending AWS keys up to the cloud without telling people. But effectively, when you look at kind of where the industry has gone with the tooling, they've all gone in this direction. They've all opened this up as an option. And as I said, for Amped, it is the default. That is the only way they want you to run, is like this. Almost at the end, apologies. So one of the other one that kind of gets grabbed is I can't leave home without my trusty debugger, i.e. don't know if it's by design or just chance, or I'm awful with debuggers. I've never really used them. I've used them occasionally, but now I never really had to unlearn this behavior with serverless, but I appreciate the fact that debuggers were and are very useful in certain contexts. But there's there are kinds of ways and means of getting pseudo debugging in Lambda functions, but it still always, again, feels a bit hacky in here. And this is kind of how to attach my debugger to my Lambda function. The answer I'd like to say is you don't. You can, but you shouldn't. And then this was the classic meme around testing that used to be like, about cowboy coding, slamming stuff into production. And then it's kind of gone on this weird kind of trajectory where actually it's like, well, no, testing in production is something everyone does. It's just not only testing in production anymore. So one of the things, there's the adage around code is read 10 times, code is read 10 times for every line that's written. But in reality, it's run thousands to millions of times for every time it's read. So realistically, production is where, production data is where the devil is. There's lots of adages around this that realistically, we need to be looking at production for understanding how our systems are actually working. The way I've tried to driven this before is beginning with the end in mind, which adopting SLOs from SRE around how do we wrap an SLO around stuff to see that things are working. Kind of like there's that red, green, new factor step with test-driven development. There's an idea of like realistically, if I'm going to define a service level objective, and I'll get into what those are for people who aren't familiar with SRE in a second, I should see my SLO fail before I see it pass. Otherwise, do I know it's actually testing the right things? Are my alerts triggered? All that kind of stuff in there. So there's kind of two key questions to answer here, and they are separate things. It's how will I know my feature is broken, and how will I determine why it's broken? And then you've got mean time to identification and mean time to recover. Mean time to recover here. So if we look at these kind of questions, these should be like any time you're building a feature, you should be kind of asking these up front to make sure you kind of got it in place first. First, you want to know how will I know it's broken, and then second, how will I determine why it's broken in here. So for people who aren't familiar with SRE, there's a concept of server level indicator, service level objective, server level agreement. Indicator is the thing that defines success or failure. So you could take it that an API needs to respond with a 2xx response code within 300 milliseconds to be counted as successful. If it doesn't, it's counted as a failure. Your SLO then defines how much am I allowed to fail. So this is where you'll hear like 2 nines, 3 nines, 4 nines, 3.5 nines, all that kind of stuff. So what you're doing is you're building this capacity to fail. And then a service level agreement, and this is one where I get very preachy about. Service level agreement is where there is a penalty for exceeding the failure goal. If you fail too much, there is some kind of balance that has to be made. So in AWS parlance, they give you service credits in response for lack of availability. Enterprises love calling things SLAs when they're SLOs. There's not normally any kind of penalty, but they call them SLAs anyway, and normally they just exist in Confluence, and there's never anything to them, and it gets very frustrating. But effectively, forget SLAs. Just focus on SLOs in terms of this new feature I want to provide. How am I going to make sure I can understand when it's failing in production, so as I deploy it and it goes out, I can see whether it's working or not. We did a container, we did an open source project around this, and this was the thing we used for managing that 600 account swarm across 3 orgs and all that kind of stuff. We built service level objectives around the AWS platform in here. As I said, it's open source. You can find your way to it. It's called Flight Controller. But effectively, this was kind of our single pane of glass for understanding everything. And you'll see like the backups and stuff like that. Like we were rolling out a new backup solution across all 3 orgs. The first thing we did was put this in place so we could see the numbers and then see the trend over time. It's just those kind of things that sometimes we get too busy in building the solution without building kind of the framework around it to understand what's happening. I really do feel you should be debugging your development with the same tools as production. I'm not a fan of having separate tools for both because you build this competence in using debuggers and all that kind of stuff and get really used to finding your way through your code assisted with tools that when you have a production outage, you can't use anymore. So rather than kind of investing all this time getting really good with local development, I'd happily take a slight hit on kind of maybe having to use tools that maybe slightly longer, as long as they're the tools I'll also have when I have a production instant. So you get things like X-Ray and things like that in AWS, which are just great to have a look at, which if you're deving in the cloud with Accelerate or others, you will get your X-Ray traces and you'll get all this stuff and you'll be able to use the same tools you'll have in prod to debug your development issues. And you're building like a really strong competence in the tools you'll need at crisis moments, as opposed to the tools you'll need when everything is fine. There's the idea, and it's now called Observability 2.0, that Charity Majors and the Honeycomb crew are really pushing. But they have this whole idea, and they talk about observability engineering, and I think it's a really interesting idea, where your ability to debug a system is about your familiarity with the debug tool, not the system itself. We've all been in the case of like, oh, the system's broken, go find the guy sitting in the corner who's been working on it for 10 years because he'll be able to figure it out, right? That's not sustainable, it's not effective, it's not efficient, all those kind of things. So this is just kind of going, well, actually, what does it look like if we actually try and make it so it's about how do I use the tool rather than understanding the intricacies of the system. There's a whole stuff about high cardinality data and lots of stuff in there. But if you go read Observability Engineering, which Honeycomb do give you the PDF for free if you go Googling ever so slightly, it's a really interesting idea to break this apart in here. And then it's kind of a case of, well, I'm building service applications, how do I leverage this in here? So just to finish up, Richard's 3 key lessons. So the testing period is a serverless anti-pattern. The unit testing component of these microservice environments is very different. So you want to be looking at, well, where's my complexity? How am I tuning my testing to target complexity as opposed to just kind of going, I'm going to unit test everything like I always used to because that's what I'm comfortable with, but kind of going, well, is it driving value? Is it effective? Is it something I should be doing? Second, emulate cloud's recipe for disappointment. If, you know, there are cases where potentially the services you want to use are expensive and localstack does provide a cheaper option, by all means, go for it. I understand that. But what I don't understand is people using it to save, to be penny wise and pound foolish with their cloud bills around testing. And the third one is testing the stop when the code hits production. Please do try and use X-Ray, CloudWatch, whatever observability tool you're using to try and drive your dev loops as well as your operational loops, because you will find it much easier when something actually goes wrong in prod if you do that versus, oh, I haven't looked at X-Ray, oh, look, I'm not instrumenting it properly, oh no, like I don't have the data I need because, you know, there's nothing worse than realizing you didn't instrument your code with the things you needed when something goes wrong in production as opposed to using drive out of your dev loops in the first place. Cool, that's it.
Questions?
Heckles, arguments, happy to take all. Does anyone use localstack day to day? Yeah. I did this talk at Woodside a couple of years ago and got in quite a heated debate with one of the heads of engineering about it because they'd used localstack on everything. I don't know if they changed, but hopefully. But yeah, it's an interesting one. Yeah.
I made a similar observation before that you made in there. It's just a comment that when you're working on platforms, your domain is IT infrastructure.
Yeah.
It's a kind of subtle inception point, but one that I think a lot of people miss. All the same theory in systems development can apply. You're just doing it on infrastructure as a domain.
Yeah, generally having AWS as domain is a lot more interesting than random business processes as well. So it's quite nice as a technologist to dive really deep into that as well. But yeah, that's an interesting one. Yeah, I think, yes.
So you mentioned that when you try to run tests in an environment that in a way is clogged, but
Yeah.
not completely, sometimes it fails.
Yeah.
Are there any, patterns or any particular ways how it fails? Can you predict it?
No, I don't think you can predict it. I know like localstack nowadays, they profess to be API compliant within like a week of the change or something like that. Like they have a lot of interesting tooling that says that they have, like they follow the API specification. But like one of the ones I had happen a while ago was the way they were, the validation against types for DynamoDB items was slightly off. And stuff, and then yeah, I was kind of deving locally, having a lovely time. Threw it up into AWS, and it blew up. I'm like, what's going on? Like, and it was just yeah, the typing, the type conforming on DynamoDB was slightly stricter than it was in localstack and that kind of stuff. But you can't really predict it. But Again, like you can run your test loops pretty much just as quick against AWS and that kind of stuff. And so yeah, I was saying to Christian before, like I've ended up in arguments with the CTO of localstack on Twitter, or X, as is now known, about this because I can't remember how we got into it, but effectively I was saying like I think I've got like a blog post version of this and I linked it, and he was like disagreeing, but you know, each their own.
Same lesson we went previously where we would develop and our local testing would be against a memory database rather than Oracle, Postgres, SQL Server. And what we're actually doing is developing against our in-memory database, not against the actual database we're using. And then you end up writing a whole heap of code to catch the edge cases.
Yeah.
And you spend more time in that area than actually doing what you should be doing.
Yeah, there's an interesting kind of idea I saw the other day of trying to track, and I don't know how you'd legitimately track it, but trying to look at where your devs are spending their time on versus the inherent complexity of the domain versus the incidental complexity of the implementation, and trying to understand where they're actually spending their time, because yeah, there's not, like sometimes you just get in this hole where you're spending your time fighting your system that you built as opposed to actually focusing on the business problem and that kind of stuff. But like it, on like that database point around like when I do clean architecture and stuff like that, there's kind of two options where whether you pass like a repo, like a repository object down in and kind of go, I'm gonna have like another, like an in-memory version of my database and drive it that way, or you kind of pass the data in wholesale at the top and do that way. I always pass the data in wholesale because of functional programming roots and wanting pure functions. In which case, I don't have an in-memory database. It doesn't exist at all. And instead I drive against Postgres or something outside and that kind of stuff. But yeah, you can like, I try and avoid bugs and all that kind of stuff as much as possible for that reason of, yeah, ends up having weird edge cases and you spend up a lot of time messing around with it when I don't really see the value anymore. Yeah.
Two things. This gentleman here, Arthur, taught me to use CloudWatch metrics,
Yeah.
which are great. It takes a bit of time up front, but just that observability is there. Something that we've been using where I'm locally is we've often got Lambda code running in VPCs.
Yeah.
And by using a protocol called TwinGate, and that actually lets us tunnel our local network to be in the VPCs.
Yeah.
Awesome. And then you can run code that's not in a Lambda, but is actually interacting with DynamoDB and S3.
Yeah.
You can actually, because I like my debugger, I like to step through my code, see what's going on. And like what I love about unit tests, you get someone else's code, rather than just read their code, step through the debugger, you can actually see what's going on in the code, see the variables change, see where it's stepping through, you get I get a far better feel for what's going on.
Yeah.
Just reading code.
Yeah, I think that's where, like, I think, so yeah, it's interesting. Yeah, you can do those tunnel things, and there is always that identity piece around I'm running stuff locally against things. You're not getting the feedback loop around identity, but
You can still do it with the same role.
you can build a Lambda execution role and then set it up so you can, there's ways and means. I think the bit around like the hexagonal architecture and all the functional core imperative shell bits means that like if I want to understand like the domain complexity and stuff, I don't have to talk to anything. I can just run that locally with all the tests and step through it however you want and explore it that way. In that way, I just find that just building that separation between the implementation deal of the data store and your domain is just an interesting way to kind of give you best of both worlds with a little bit of rigor, and it doesn't come for free, but I find that quite effective. But yeah, to each their own. Like it's interesting to explore this. Like I quite like the feedback I get because people have different experiences. Go here and then you can. Sorry.
Thanks. I was just going to mention that.
Yeah.
So yeah, awesome talk. Work in serverless. We use SST at work.
Yeah.
And it uses MQTT to create tunnel, and
Yeah.
I do that with the debugger, able to run through basically all the code. Where it comes really handy, we use hexagonal, actually we use clean architecture. Where it comes really handy is we don't have great contract tests at the moment. So when we're talking to external systems, we've got really good integration tests and end-to-end tests for our domain, but as soon as we have like events being emitted, that debugger allows us to kind of reach into these other bits of code that aren't really well tested and just see what the interactions are, and we're able to find bugs. So it's like not the best way of dealing with that problem, but
you gotta find your way through, right? And sometimes you can find compensating actions. You're like, this isn't ideal, but it kind of gets us moving today, and that's better than not moving at all, right? I must admit, I haven't tried. The live Lambda thing with ST. I haven't tried it yet, but I saw it. Oh, that's interesting. A different way. I've been using SAM and CDK and AMP for a while, so been on the other implementation side. But then when I read about them, that's a cool idea. But they reckon it's like much faster because you don't have to stream your code changes up. So yeah, I'll have to give it a crack at some point.
second point
Yeah.
of observability is logging like specific variables so that you can pick them up in CloudWatch has been something that has really helped us. And there's a new, very late AWS development in terms of, I can't remember what it is, but basically it allows you to log different things, and you can create like a mesh between your different services, and it allows you to step through in a similar way to the debugger, but from an observability perspective, so then you can get stacks that mesh together.
Yeah, with like correlational causation, so ID, something like that. Yeah, I think I quite like Honeycomb. Honeycomb's just general approach, I think, is generally the way to go with arbitrarily wide events of high cardinality and that kind of stuff to kind of give you everything while only storing it the once. Unfortunately, I only get to use it for personal projects because of the InfoSec run-up time at Enterprise is just too long to get it in place, so we end up using CloudWatch and similar just because it's there. But yeah, it's interesting to see what people do in that space. I think it was. Yeah.
I just wanted to mention the step-through debugging, which is a pretty standard way of doing it, which a lot of people probably know about already. But using SAM and the AWS toolkit in your IDE and running it in a local container in Docker desktop. So it's Lambda is running in your local machine, but it's still connecting out to the services, and it supports all the step-through debugging.
Yeah, I do wonder if there's a slight generational divide around the debugging tools. I think I've somewhat grown up in somewhat grown up in a blissful world of ignorance and kind of got away with some of it, I think. But yeah, you can do that debugger. I think it's just I always come back to like a debugger's not there in prod when I need it. And yeah, it's good for local development cycles. But yeah, I try and optimize for when prod's gone down and everything's a crisis, and I want to be very I find X-ray distributed tracing just out of the AWS services like the most impactful. And what I found when experimenting with that and building it en masse was if I didn't use it for the dev loops, I wouldn't instrument it very well. But then using it for dev loops and trying to use it as a debugging made me go and instrument it with all the interesting things, because the other instrumentation is kind of like, Like you need to be putting kind of all the critical like searchable data up into the traces, and you can find it when you need it and stuff. And I don't know. I could have just been a better engineer and realized I need to do that without the dev loop there, but I found it effective for me at least.
So you showcased 100% test coverage.
Yeah.
But at other points you mentioned, that you don't want to be testing everything at that level. You need to go to end-to-end testing, stuff like that. To get 100% coverage means you've got no dead ends in your code. For example, you're not catching an exception in 2 different places and trying to handle it because you end up with dead end code. So the question is, to get to 100%, how much effort did you have to go through to make your code perfect?
Not a lot. I rather than throwing exceptions, I'd return ethers and then return errors. So I'd use like functional paradigms to kind of rely on the tight system to enforce I was handling everything as it came up and that kind of stuff. Try catch and throwing is not a fan generally. I generally lean on like, even in Python, I end up using like either types or optional types to be able to kind of rely on the type system, using MyPy in Python to make sure I'm being a good citizen and that kind of stuff. But yeah, throwing exceptions because you can kind of ignore and let it bubble up and that kind of stuff, and it gets really problematic. But if you use your type system returning eithers and that kind of stuff, you can kind of enforce it from there. But like, to be clear, that 100% coverage required on me doing integration testing as well. But because I've got like a layer which is just talking to AWS, I just run it against AWS and test that as well, and I test like everything together. So my unit testing is just doing domain, and then my drivers are separate. But then when I do coverage, I do drivers and domain combined and get it that way, and I get full coverage.
How did that get with the bulk being more black box testing than white box testing? Did you get that level of test?
Trying to think, I've got it open. If you take, because that was done with clean architecture, let me find the clean architecture diagram. I have no internet. Thinking. Do I have another slide with the clean architecture? Trying to think about it. So no, I'd have specific kind of layers and then use TDD to kind of drive it out from there. But I'd be testing at like, if you go look at clean architecture, I'm testing at like use case layer, adapter layer, and then driver testing out. And then there'd just be some test to kind of just get the main function and just try kind of a simple end-to-end of hooking the drivers in and that kind of stuff. But it wasn't a huge amount. But then I'd have like, if I wanted to swap from Dynamo to Postgres for data storage, for example, or something, I'd just have to go implement a new driver and pull that in and rewrite the test for the driver, but my domain wouldn't change at all. It's very easy with event sourcing as well, which is what I do most of the time, because the amount of functions you actually have to do against the database are actually super limited. So you only have a very small surface to actually write in there. There's only kind of, at a minimum level, there's only three things you need your database to do, that's it. And everything falls into those patterns. But yeah, like you can, I don't know. I find TDD and clean architecture kind of gives me a good path forward for most stuff, and gives me good layers to test that. But I've got like a client work at the moment. They've got like 80% coverage, and they're pushing for the client's pushing for higher percentage coverage. I'm like, I'd rather do contract testing because I think that will catch more of what we want. The unit testing will catch some, but contract testing will probably catch what unit testing would have caught plus more, and I'd rather focus there than look at upping it from 80 to 100. I think unit test coverage never goes up, it only ever goes down. So I always start at 100 and then get beat down over the months and years, rather than start at 80, because I know it's never going to go above that ever again. I've never seen it ever go up. I'll on Twitter or LinkedIn or something, I'll dig out the repo where I had those examples from. You can have a look at the code there for how we did it.
Okay, John again, thank you very much.